Hello, this is Martha from the Academic Support Center. Once again, we're continuing with our Pre-Calculus 1 review. Hopefully we can get through problems 23 to 27. Let's get going. 23 reads, determine tail end behaviors of the graph of the function negative 4x cubed, blah, 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 blah. Really, the only thing that we need to worry about right here is the leading coefficient with the highest exponent. So our exponent is odd because it's x to the third, and our coefficient is negative because it's negative 4x. So just as a quick review, if our leading coefficient is even, it looks like our tail's going up and up, even and positive. The tails go up and up. If it's even and negative, they go down and down. Now, if it's odd and positive, it looks like that x cubed function. But it's negative, which means it's flipped around. So our tails, as we go to negative infinity, they go up. And as we go to positive infinity, they go down. That's our end behavior. All right, find all the real zeros of this function. Okay, we could do synthetic division, but let's see if we can't factor this out a little bit. Let's try factoring by grouping. Out of these two, x cubed plus 3x squared, I can pull out an x squared. So that gives me x squared times x plus 3. Now, if I look at the second set of grouping over here, negative 16x minus 4. If I pull out a negative 16, I'm left with x plus 3. And I can factor this x plus 3 out of both terms, so I get x plus 3 times x squared minus 16. Now I'm pretty close, but I'm not fully done yet because I have this x squared minus 16 is a perfect square. So I get my final breakdown is x plus 3 times x minus 4 and x plus 4. That means to find all the real zeros, I set this equal to each other. Or each term equal to 0. So if I set x plus 3 equal to 0 and solve, I subtract 3 from each side, and that gives me negative 3. Over here, the next term, x minus 4, if we set that equal to 0, we would add 4 to each side. So I get that x equals 4. And this last one, x plus 4, if I set that equal to 0, I would subtract 4 from each side, leaving me with x equals negative 4. So all the real zeros are negative 4, negative 3, and positive 4. There we go. Now we're going to find a polynomial. 25 says find a polynomial function in factored form with the given zeros and their multiplicity. So luckily it's in factored form, which means I've got my parentheses and I've broken it down into its basic groups. So let's see what we've got. We've got negative 2 with a multiplicity of 2. So let's look at that one really quickly. Remember, the form for this follows x minus a or x minus something. So if we have x minus negative 2, that's the same as x plus 2. And with a multiplicity of 2, meaning that that term is squared. Now let's look at our next terms. We've got 1, and we put it into this format, x minus a. So that gives us x minus 1. And we've got two imaginary roots, so 3i and negative 3i. And that's always with the conjugate pair where you have one positive and one negative. So if we have x minus 3i and then x minus negative 3i, and this is negative makes positive. So our final answer reads x plus 2 with a multiplicity of 2. And then we're told that each of the following factors have a multiplicity of 1. So x minus 1, x minus 3i, and x plus 3i. Now, because it's in factored form, we don't have to multiply this out. Yay! So 26, list the possible rational zeros of the function. Now, with this, we want to remember that it's p over q. P meaning posterior, and q is beginning. We put the factors of that together. So the factors of p are positive and negative 1 and 2. And then the factors of 3, our coefficient there, q, are positive and negative 1 and 3. So we're going to list these out with a big old plus or minus out front. And we'll do 1 over 1 or 1, 2 over 1 or 2. And then we do 1 over 3, so positive and negative 1/3, and then positive and negative 2/3. And those are the possible rational zeros of this function by taking the p for the posterior, the factors of the in term, and then putting them over the factors of the initial term, that 3x to the 5th, the highest coefficient. All right, moving on to 27. Given the function f of x equals 2x cubed plus 3x squared minus 8x plus 3. So first we want to find all the zeros of the function. And then we're going to write it in factored as a product of its factors with the parentheses, and then we're going to sketch the following zeros. Now for this, it doesn't look like we could really true factoring with grouping. So let's look at what we've got for our possible zeros. We take our p over our q. So p, the factors are 1, 3, positive and negative. And then the factors for 2 are 1 and 2. So this is 1 over 1 and 3 over 1, or just 1 and 3. And then we take 1 over 2 and 1 over 3. Or 2, sorry, 3 over 2. There we go. And these are our possible factors. Now we get to use synthetic division and see what's left, see what we can work out. So let's start with 1. And we've got x cubed, x squared, x to the first, and then our constant. So luckily we don't need, it's all filled in and we're good there. So we've got 2, 3, negative 8, and 3. And if we go through and if we get a 0 after we do synthetic division, we know that it's a root. So we bring this 2 down. 2 times 1 is 2. We put that here. We add these together. 2 plus 3 is 5. 1 times 5 is 5. And then we get negative 8 plus 5 gives us negative 3. Negative 3 times 1 is negative 3. We add 3 and negative 3 and we get that 0. So we know that negative 1 is a root. So that's great news. And that's x minus 1 because we're still use that form of x minus a. And we can continue using synthetic division here because if we remember we've taken care of one of the x's, so this is the same as 2x squared plus 5x minus 3. Now let's try and figure out another one of our factors here. Let's give negative 3 a try. You could also do the rule of signs to try and figure out how many negative and positive to help you here. So let's do negative 3. We've got 2, 5, negative 3. So we're going to do 3, bring the 2 down. We get 2. 2 times negative 3 is negative 6. 5 plus negative 6 is negative 1. -1 times -3 is +3. We add -3 and +3, we get that as a 0 as our remainder, so we know that our another factor is x minus -3, or x plus 3. For this last one, we don't have to do any more synthetic division because we've gone from x cubed to x squared, now just to x. And we know that this is 2x minus 1 is our last factor, which is pretty nifty. We know that means that our zeros are, our factors are x minus 1, 2x minus 1, and x plus 3. If we set each of these factors equal to 0, x minus 1, we add 1 to each side, that means that 1 is a real root. And it's an it's an odd multiplicity, so we know that it crosses there. Now we take 2x minus 1, set that equal to 0. We add 1 to both sides. That gives us 2x equals 1. We divide by 2, and that gives us x equals 1/2. So we know that that is another root, or where it crosses the x-axis. And again, an odd multiplicity, meaning that it crosses at that point. And then we get x plus 3. X plus 3, if we set that equal to 0, we subtract 3 from each side, and we're left with x equals -3. So let's see if we can graph this a little bit. We know we have a 0 at 1/2, at 1, and over here at -3. Now, how do we take care of graphing this? We look for the end behaviors, and we have our highest exponent is 2x to the third. That means it's positive and it's odd. And going back to our end tails, we know that it looks like that x cubed, or as it goes to -infinity, it goes down. As it goes to +infinity, it goes up. So I always draw those last. Yoop. And I know that it's going to cross at each of these points, but I can do a little bit better for my graphing. I can find my y-intercept. And with the y-intercept, you put 0 in for your x's. So we've got 0 minus 1. We're breaking it down into factors makes it nice and easy. 2 times 0 minus 1, and 0 plus 3. 0 minus 1 is -1. 2 times 0 is 0, minus 1 is -1. And then 0 plus 3 is 3. -1 times -1 is +1. And 1 times 3 is 3. So I know that it hits the y-axis at 3. And that's my y-intercept. And it crosses at each of these roots because of the odd multiplicity. So it's going to go up, hit 3, cross at 1/2, cross at 1, and that's how we find the zeros of the function, write the function as a product of its factors, and sketch it. All right, on to more fun.